New calculus channel. My name is John Gabriel, and I'm going to be dealing with a very simple little arithmetic example just to show you how far off the beaten path mainstream academics have gone. So let's start. Now, when you learn about, let's say, something like fraction division, they simply throw rules at you. But if those incorrigible apes who are your math teachers and math lecturers studied Euclid's elements, they would know of something called Book 5 and Proposition 12. By the way, this single proposition allows you to do all the four operations of arithmetic, okay, with no problem whatsoever. Difference, sum, quotient, and product. And you can do them all with simply adding, except for difference, because difference comes before addition. You can define addition in terms of difference, but you cannot define difference in terms of addition. So the order of operations are first difference, then sum, then quotient, and last multiplication. You cannot get quotient from multiplication, only the other way around. Okay. And you may ask why? Well, if you write anything like P over Q, then you've already done the process. You've already completed the process of division. Okay, I'm not going to go into that. Now, how do we do this? Well, it's very simple. From proposition 12, we can just rewrite this as 3/5 over 7/2. And then we can say, all right, just keep on adding them until we get whole numbers, okay? So we'll add the top here as well, 3/5 plus 3/5, like that, okay? And that will give us 6/5 over 14/2, which is just 7. So we got a 7 at the bottom, no problem. Now we want to get a single number at the top, okay? And we know that if we add this 5 times, and we have to do the same at the bottom, 5 times as well. Then on top here, we're going to get 30 over 5, which is 6. And at the bottom, we're going to get 35. So the answer to this is 6 over 35. Okay. And normally how they'll teach you to do it is they'll tell you it's 3/5 times 2 over 7. Yep. Which gives you 6 over 35. Now, notice in this part here, where I added the two together like this, I could have just said multiplied by 2 on both of them, right? That's because I added it twice, in which case the 2's disappear and you just have 7 and you have 6 over 5 instead of actually doing this. And that's a neat little trick I wanted to show you from Proposition 12, Book 5 of Euclid. And it turns out that that proposition is dealing with similar triangles, even though no mention of those is made there. So let's say, for example, if this section here was 3/5 and this was 7/2, then if you just carried on increasing the sides by the same amount, then this would still be in proportion to this side, maintaining the original proportion of 3/5 to 7/2. If you're not already subscribed to my channel, become a subscriber, click like, tell your friends about this, follow me on Academia.edu, and let's make this the best math channel on the web. I'm John Gabriel.